Hello students, in this video I am going to explain electrophilic substitution reactions of aromatic molecules. This is Organic Chemverse YouTube channel. In this series of videos I am going to solve some of the multiple choice questions from hydrocarbons chapter. Let's get started. There is a toluene molecule. So what is toluene? You should know that toluene is a methyl benzene molecule. When toluene is treated with an electrophile, remember in organic chemistry the electrophile is commonly written as E+. It is going to form an ortho complex. Then what is ortho complex? Ortho refers to a position of carbon on the benzene ring. Generally on benzene ring there will be hydrogens. If hydrogen is substituted by some R group, right? So the R group can be methyl, ethyl, right? So this carbon is called as ipso carbon. The carbon next to it is called as ortho, next to that called as meta, and we have a para carbon. Okay, ortho, meta, para. Now they're saying you're going to get a ortho complex. All right, so that means what? The electrophile E is going to the ortho position. Then the rate of this reaction, say it is R1. That step of attacking electrophile, they are saying it is R1. Okay. Similarly, we have toluene, that is methyl benzene. It is also reacting with an electrophile. Say it can be a nitro or maybe methyl, or it can be even Cl+, right? So any electrophile. Say let's assume if it goes to meta position. Okay, if it's going to meta position, the formation of this is through a carbocation, right? So the rate of that would be R2. The formation of that meta complex is R2. So here you see that it is going to meta position. Now we are supposed to find out the rate of these reactions. Okay, so the formation of the complex we need to identify whether R1 is greater than R2 or R2 is greater than R1, or will it be same. Now first let's understand what is electrophilic substitution reaction, because it is an example for electrophilic substitution reaction. On benzene ring, the hydrogen is being substituted or replaced by an electrophile which is electron deficient, right? And it will form a product, and that is called as electrophilic substitution reaction. If there are no other groups on the benzene ring, it's just benzene, the hydrogen can be replaced anywhere. But if there is already a group present on the benzene ring, like in this case, then the incoming group, where it will go, ortho, meta, para, depends on the existing group on the benzene ring. There are two types of groups. One is electron donating groups, the other one is electron withdrawing groups. Electron donating groups are the one which donates electron to the benzene ring and makes it more electron rich. The electron donating groups are, some of the examples are methyl group, ethyl group, OH, NH2. These are some of the groups which will give the electrons to the benzene ring either through inductive effect or through resonance effect and makes the benzene ring electron rich. Remember, the electron donating group always enhances the electron density on ortho and para position. That's why these are also called as ortho para directing groups. If there are electron withdrawing groups like nitro, aldehyde, ketone, carboxylic acid, right? So all these are electron withdrawing groups through either minus I or minus R, that is negative inductive effect and negative resonance effect. Then they are predominantly meta directing groups. That means what? The incoming electrophile prefers to go to meta position. Now this is the fundamental concept. Now let's see what is this group. This is a methyl group. Methyl means it is electron donating through inductive effect. That means what? It increases electron density on ortho and para. So the incoming electrophile prefers to go to ortho means its rate would be greater, right? So when it goes to meta, it's going to form a meta complex which will not be stable, so the rate is less. Therefore the R1 is greater than R2. So that is the right answer. The right option here is option A. Thank you for watching this video, and if you still have any confusion on this topic or any other topic, you can send me your doubts either through email or you can drop them in the comment box. Thank you.